You're watching the 3.8 lesson video on finding equations of linear functions notes. Today in this video, we are going to talk about mostly the slope-intercept form of a line. So using the slope-intercept form or being able to use a slope-intercept form is really nice because it helps us, number one, to graph things better, but also a lot of times when we model an equation in a table of values, using the slope-intercept form can be really helpful with finding how to model a situation algebraically. All right, so let's dive right in. We have a graph, okay? A couple things that I'm noticing about this graph is that my scale is kind of weird on the y-axis. So it looks like each one of these lines we are going up by 4s, okay? So like this is 4, this is 12, so on and so forth. So I have a couple important points here. Okay, I just plotted the y-intercept because let's use y equals mx plus b to help model this graph using algebra. So we're going to write an equation of this linear function. So in order to do that, we need our m, which is our slope, and our b, which is the y-intercept. So on this graph, I can see pretty easily that my y-intercept is a point 0, 84. So that 84 is going to go right on into my b. But now I need to find the slope. Remember, slope is rise over run. So let's find some nice, pretty points and figure out what is going on. Okay, so let's use these 2 points here, this guy and this guy. I went down from 72, I went down 4, 8, and another set of 4 would be, I went down 12. So I went down 12, and I went to the right. Well, let's be careful of our scale here. That's 1, 2, 3. Okay, so my scale on the x-axis is cool. It didn't change the way that the y did. So I went down 12 to the right 1, which means that my slope, my m, is negative 12 over 1, which we can also write as negative 12. So if I put these together, that's my m, I am going to have the equation y is equal to negative 12x plus b, which was, what was that, 84? 84. And actually, I'm going to be a little bit more careful. Instead of using y, they told us our function is f of x. So let's label this f of x equals all of this. Okay, so now I have this, but I really just want to make sure that I didn't make a mistake. So let's head over to our calculator. Pause the video if you need to grab yours. And we're going to do a new graph. We already have it in function notation. So negative 12x plus 84. I'm going to hit enter, and that looks really weird. So right away you might be like, oh, we graphed this wrong, but hold on a second. My graph is only going up to 6.67. This one, my y-intercept is at 84. So let's go all the way up to 100, and let's see if it looks somewhat similar. Okay, it's looking a lot better. So we could either use our table of values or we could use the trace feature to see if this is right or not. I'm going to use my table of values because it's in function notation. So Control T, our y-intercept is 0.84 here, 0.84 there. Ooh, I'm happy. This is a point 172, 172, 260, 260, 348, 348. I am a happy girl because I just was able to figure out that what I did was correct. Okay, let's head down to our second example where we're given a table of values. Okay, let's think back to what I said. Let's try to use y equals mx plus b to help us. So in order to come up with this equation, I need a slope and I need a y-intercept. So let's find the rate of change and let's hope that it's a constant Is it 5 to 10 to 15 to 20 to 25? Yes, we're adding 5. What's going on with my y values? What's going on with those? 280 to 265, 265 to 250, and so on and so forth. If you saw that those are going down by 15, you are a rock star, because you are right. So when we want to find the slope, remember slope is rise, so our y values divided by our x values. So these are our y's, these are our x's. So the y change divided by the x change would be negative 15 divided by 5, which is negative 3. So y is now g of m. So g of m is equal to my slope, which is negative 3, with my x value, which is now the variable m, plus my y-intercept. But bummer, the y-intercept isn't in the table. But it's easy to find if we just use our pattern. So if I go back 5, don't I get the 0? Isn't that my y-intercept is when x is 0, or in this case, m? So if I go back 5 that way, if this was subtracting 15 going to the right, I can add 15 going to the left, which would get me 295. So my y-intercept is a positive 295. All right, Control Doc and add a graph. Let's check. You know what I'm doing. So 3, well, my calculator doesn't understand m, so I got to bring an x. Plus 295. Enter. Well, it's not there because my y-intercept is at 295. So it looks like it's missing, but if I did change that to maybe, like, I don't know, 300, we're at least seeing part of the graph. So it's there. All right. But for the sake of what we need it for, let's just look at the table of values. 0, 295. 5, 280. Yes. 10, 265. 15, 250. So we're in very good shape. We now have just proved that our equation here models the table of values that they gave us. All right. Now from a scenario, let's see what's happening here. So Taylor's a barista. She's at a local coffee shop and she makes a caramel macchiato and it requires 2 pumps of caramel sauce per 5 ounces of coffee. Wow. Okay. So write an equation that can be used to determine how many pumps of caramel, P of x. Ooh, let's set up a table. All right, needed for x ounces of coffee. So x ounces and, whoa, let me draw a little bit more of a straight line. And then P of x, what was P of x? Pumps of caramel. Okay, so what do we know? Well, her signature caramel macchiato is 2 pumps for 5 ounces. All right, so 2 pumps for 5 ounces. So what if she doubled the pumps? 4 pumps would be 10 ounces. What about 6 pumps? 15. And then 8 would be 20. Okay, does anybody know why I left a big giant spot there for another point? If you're thinking because we need the y-intercept, you're a rock star. We do. So let's work backwards. That's 0 because I'm going up by 5s every time, right? So 5, 10, 15. Yeah, I'm going up by 5s. So I subtracted 5 to get to that 0. And then here I was adding 2 every time, 2 pumps. So I can subtract 2. Interesting. So my y-intercept is at the origin. All right, let's put it all together. Y equals mx plus b, right? I'm going to write it out if it will let me. Okay, thank you. Y equals mx plus b. Our y is p of x. So p of x is equal to our slope, which is change in y divided by change in x. So 2/5 x plus my y-intercept, which is 0. So I could put plus 0, or I could leave it. I'm just going to leave it. You know where I'm going. Control Doc. Add a graph. We're checking this. All right. So we want to graph 2/5 x. Press enter. We got function mode, so I'm going to control T this. 0, 0. Yes. 5, 2. Yes. 10, 4. Yes. So we are in very good shape. As you can see, we are now using our technology to help us verify that we are indeed correct.